Right, children? So now we will go for the echo and its application. So due to the technical problem, we have concluded by the Doppler effect only. Now we'll go for and beats also. Now we'll go for echo and its application. EchoSabines formula and reverberation time. And if time permits, you'll go for a simple pendulum also. And what is echo? Echo and its application. So the definition of echo is right. I will study with. I'll go for echo only. There is some disturbance, I think. A repeated sound that is caused by reflection of sound waves from the surface. The sound is heard more than once because of the time difference between the initial production of the sound waves and their return from the reflecting surface. So generally, the repeated sound that is caused by a reflection of sound waves from the surface, the sound is heard more than once because of the time difference and the position between the initial production of sound waves and the return from the reflecting surface. And to tell the fact, actually, uh, echoes are heard due to the position, different positions also. Okay, so for example, I will give you an example for echo also. Just general definition is the reflected sound from a distance obstacle. The reflected sound from a distant obstacle is called echo, right? I will check out the video here first of all, so that it may not disturb. Now, the reflected sound from the distance obstacle is called an echo. And if I explain, let us consider a sound which is produced at a point A from a distance of x where the obstacle is there. So the observer at a point A first listens the original sound and then the reflected sound which was reflected by an obstacle from the point x in its path. The reflected sound is called here echo. So the general examples are, if a person stood in front of a mountain cliff, then there you could hear the echo. And a top long covered building, or if roof with a high ceiling, high height, large height ceilings, there also you can hear the echo. That means there should not be a distance of 17.5 or 16.5 meters more than the sound producer and the obstacle, right? A heavy body should not be away more than the 16.5 meters from the sound source or observer, isn't it? So there is a general formula. What is the formula for echo? Distance is equal to velocity into time by 2. I repeat again, distance is equal to velocity into time by 2. Here children, the velocity of sound is 340 meters per second, and the time taken or the persistence of sound to hear the echo or beats is just 0.1 second by 2. That means 340 into 0.1 by 2, that is 17 meters, isn't it? That means 16.5 to 17 meters. Beyond that, below that you cannot hear the echo sound, but beyond that you will hear the echo sound. Many times when I was in my childhood, I used to go under the water tank, a big water tank, more than some lakhs of liter or 40 lakhs liter. That means a tank which is constructed for the complete town. Okay, so big towns or areas. So under it, if you stand and if you clap once, you will be able to hear 2-3 claps, isn't it? So I used to, it used to be somewhat entertaining to me hearing that sound. So you people might have did this, but uh, when I used to go for grazing the cattle in forest or hill areas, there also I used to hear, if I call my friend, I used to hear the another voice, the same repeated voice from the cliff. So there I came to know that why it is, I was been confused, because I don't have the knowledge on echo at that moment, right? But you people might have did all these things, and if you didn't, you can now. So dolphins, you know children, these dolphins detect their enemy and obstacle by emitting the ultrasonic waves and hearing their echo. To see their knowledge, dolphins, they detect their enemies and obstacles. That means huge animals or huge body or any huge mountain inside the ocean, they could detect themselves by producing some ultrasonic sounds. That means the dolphin sound will be very heavy, large sounds they will produce, and hearing them echo back. Similarly, bats also, in the night time, bats don't have the eyes, what you call, right? So what they do, they generate sound, and they will listen the echo, whether the obstacle is at what distance the obstacles are there or object is there in its flying direction, and that's why speedily they can cross us without hitting, isn't it? So it is in medical science, the echo method of ultrasonic wave is used for imaging the human organs such as the liver, gallbladder, uterus, womb, etc. Yeah. So in by using the by sending the ultrasonic sounds on a pregnant ladies, the gynec doctor, they will study the condition of baby, and gallbladder, uterus, kidney stones. For kidney stones also they will use this sonography. Sonography is nothing but sound generated graph. Echograph is called sonography. And yeah, womb means garbham, right? So the study of the condition of womb or a baby's condition or heartbeat condition, everything will be studied based on this echo children. So this is a very very medical advantage concept or theory. Okay, and coming to Sabines formula, yeah, Sabine is a name of scientist actually, W.C. Sabine, I think German scientist. So this fellow, he has given theory. He proposed one theory, and based on this theory, and he formulated one formula also. So based on that formula, on the honor of his name, he has the formula has been named on his honor. So he improved empirically one relation, t is equal to some 0.4 by 4v by summation of a. Okay, where t is a reverberation time. That means t is equal to 0.49 into v by summation of a. Summation of a is nothing but small a1 into s1, a plus a2 into s2, small a3 into s3 plus s3, small a4 into s4, and so on. That's why I have added this summation of capital A, where capital A is a product of small a and small s. Then let us see what are the small a and small s here. Children, here t stands for reverberation time, and 0.49 is a constant value, v is a volume of enclosure, and small a1 is a absorption coefficient of a material, and s1 is a nature of the surface area. Suppose in different areas, cinema theatres, the ceilings are done by what we call plaster of Paris or thermocol or wood. Side walls are in cinema theaters also made up of wood, because due to the number of vibrations, the cracks may get to the wall. So that's why to avoid these things, generally auditoriums also they have good ventilations, isn't it? So absorption of coefficient, absorption of sound is there more for wood. That's why in cinema theaters the more absorption coefficient materials are used. Okay, and otherwise we will hear the reverberation sound first of all. So to avoid this reverberation points, Sabines theory assumes continuous decay of room energy. The energy loss through walls assumed to occur at the same instant as energy loss from room volume. So, Eyring formula assumes energy loss uh, occurs to each discrete reflection of sound ray, children, and reverberation time. Let us study now. What is a reverberation? A reverberation is an echoing sound multiple times. When you bang on a big piece of a metal, you can hear the reverberation even after you stop banging. Banging is nothing but hitting. So, the repeating, often low booming sound that flows the strum of an electric guitar or the thump of a drumsticks on a cymbal is called reverberation. For example, if you take if I speak, if I am in an enclosure, that means a classroom which is completely closed. Okay, in that closed classroom, if I speak or use one word, if I take Rahul, if I ask Rahul and if I shout once in a closed enclosure, the people of a person around the what we call people who are in enclosure, they will hear that Rahul sound many times within a 0.1 second, because due to the multiple reflections of the left wall, right wall, roof and back wall, isn't it, and multiple reflections of windows, doors, one after the another, the reflected ray which is far away, they will be reaching on your ears for a long time, isn't it? So that's why this is the phenomena which takes place in an enclosure. Okay, if it is open, in that case you will not hear. If I shout Rahul only one time, or sometimes you may not also hear, isn't it? But when I speak in an enclosure, many times you will hear the Rahul, 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 but in a fraction of seconds. Okay, it takes very less time. And coming, children, the reverberation time. Reverberation time is required for the sound fade away. The sound will fade away. Fade ante decay of sound, a decrease or completely becomes zero of that sound. Okay, reverberation reduces when the reflection the hits surfaces it can absorb sound such as curtains, chairs and even people. So the reverberation time of the room space is defined as the time it takes the sound to decay by 60 decibels. Generally, if I speak 80 decibels and it will fall down to 60 decibels, how much time it has taken? That is the reverberation time. It will be just 1/10th of that second, children. That's why these people, to avoid the reverberation time and reverberation, large sound of large areas, the meetings of politicians and any functions, they must be carried out in a wide area, in a ground, to avoid this reverberation. And a person who is speaking or who is addressing the meeting has to give some gap without continuous speaking లేకుండా కొంత గ్యాప్ ఇవ్వాలి. గ్యాప్ ఇస్తే ఏమవుతుంది, ద వాయిస్ అనేది క్లియర్గా మీ చెవులకు చేరుతుంది. Got it? So you have to give some gap to get the clear sound. That's why these people, politicians, dear friends, dear students అనుకుంటా మాట్లాడతారు. Why they will give gap? Why can't they speak good morning children, good afternoon children, and tomorrow we are going to conduct so and so meeting and program? Continuously you cannot speak. If you give the gap, the voice will be clear for the audience, isn't it? For every syllable, there should be some gap that is of minimum 0.1 second. So this is the all regarding what do you call, children? Sabines formula and echo. Now we'll go for next topic, that is a simple pendulum, right? Simple pendulum, where it is, again I'll go back, I'll get some PPT, yeah, here is that PPT 5, okay, yeah, this is a simple pendulum, children. What is simple pendulum? Definition of ideal simple pendulum: consisting of a point mass suspended by a weightless, inextensible, perfectly flexible thread or a string, free to vibrate without friction. A very critic definition. Chudandi, emantaru? Simple pendulum, an ideal simple pendulum consisting of a point mass, suspended, where to suspend and what type of nature it should have, that string, inextensible, సాగకూడదు, perfectly, ఖచ్చితంగా, and flexible, without wrinkles or folds, thread, non-stretchable, inextensible and non-stretchable, it should not stretch due to the weight when it swings, and it has to vibrate without friction. Generally the ideal simple pendulum is not there, but this is the exact definition for ideal simple pendulum. And children, now coming to important terms. The oscillatory motion of a simple pendulum. Oscillatory motion is defined as the to and fro motion of a pendulum in a periodic fashion, and the center point of oscillation known as equilibrium position. Here oscillatory motion is to and fro motion. The motion of pendulum must be in a periodic, that means it must take the exact time. I think you are well known with the periodic motion. The regular interval of time, the motion which repeats in a regular interval of time, is called periodic motion, and the center point of the oscillatory motion is known as equilibrium motion, and end points of the periodic motion is called extreme points. Okay, center point is equilibrium position or mean position in some books, and the end points are called extreme positions. And the time period of simple pendulum is defined as the time taken by the pendulum to finish one full oscillation in a unit time. That means how much time it has taken for one oscillation. Okay, full oscillation ki తీసుకున్నటువంటి time, that will give you the time period of simple pendulum. And you think you have to remember, children, periodic motion is a regular interval of time, and in ESET they have asked which of the following is correct. In first bit they have asked every simple pendulum motion of simple harmonic motion is a periodic motion, every periodic motion is a simple harmonic motion, both are correct, like that. So the thing is, every simple harmonic motion is periodic motion, but every periodic motion is not simple harmonic motion, because periodic motion may be sometimes linear, periodic motion may be sometimes circular, isn't it? Periodic motion, that means there is no to and fro in a periodic motion. Periodic motion is a circular motion in case of circular motion. So circular motion cannot comes under simple harmonic motion. The normal or a projection of a point projected with reference to the circular motion will give you the simple harmonic motion, but circular motion is not a simple harmonic motion. This to be noted. Now coming to the amplitude, children. The amplitude of simple pendulum. The maximum displacement from the mean point to extreme point on either side. Mean position నుంచి extreme point ఉన్నటువంటి distance ని amplitude అంటారు. Distance travelled by the pendulum from the equilibrium position to one side, any one side. that is amplitude. And the length of the simple pendulum is defined as the distance between the point of the suspension to center of the bob and is denoted by T. Here the bob is nothing but point heavy mass. ఇంతకుముందు మనం ఏదైతే హెవీ మాస్ అనుకున్నామో పాయింట్ హెవీ మాస్ దాన్ని ఏమంటారంటే బాబ్. హియర్ ఇన్ కేస్ ఆఫ్ సింపుల్ pendulum they will take one spherical ball. Bob is nothing but a spherical ball, right? A bob తీసుకొని with the help of hook, one hook is projected on that spherical ball, with the then the thread is tied to somewhere and point of suspension is placed somewhere to a retort stand or somewhere hanged, right? Then it will be called as a simple pendulum. But the length of the pendulum is not till the bottom of the bob. The length must be considered to the center of the bob, children. Okay, center of the bob to fixed point or fixed point of suspension, right? So these are all these small definitions. And frequency, what is frequency? The number of oscillations made in a unit time. Number of oscillations made in a unit time. For in case of oka నిమిషంలో it takes 2 minutes 2 oscillations, then the frequency of that simple pendulum is 2. Okay, so small little bit definition: simple pendulum, time period of simple pendulum, amplitude of simple pendulum, length of the simple pendulum, and frequency. Now derivation of the time period of simple pendulum is also one of the long answer which we can expect. So yeah, one by one slit I can show you the derivation of time period. Okay, the point mass suspended from the end of a light inextensible string whose upper end is fixed to a rigid support. The mass displaced from its mean position. Now there are a negligible frictions from the air and the system. The arm of the pendulum does not bend or compress and is massless pendulum. Swing is in a perfect plane, children. Gravity remains constant. The time period of energy of simple pendulum derivation you see here. First assumption, what we have to assume? There should be a negligible friction with the air, and there is no air in our lab and or in the system. The arm of the pendulum does not bend or compress. There should be a massless. If it is mass also, it doesn't matter. It is independent of shape, size and material and all. Okay, anything you can hang, but there should not be a friction. The pendulum swings in a perfect plane. Gravity remains constant. Where gravity must be constant. Generally at some hundreds of kilometers the gravity will be at the same, children. The time period of energy of simple pendulum derivation, let us check. We know that T minus mg cos theta is equal to mv square L. This is the equation of motion. This is the equation of motion. T minus mg cos theta is equal to tension minus mg cos theta is equal to mv square L. So figure of the pendulum of derivation you see here in this figure. Length is a length of the pendulum L, and A is a equilibrium position. Okay, and T is a tension, where theta is the angle between the equilibrium and mean point. Then you could see mg sin theta towards the equilibrium point, mg cos theta which is balanced by the tension of the thread. Mg is a weight downwards to the pendulum. Okay, children. Actually this has to give some A and B positions for extreme points, but he didn't mention here. Okay, now yeah, this you could see, you can have a figure here, you can draw చేసుకోవచ్చు, right? Now the torque tending to bring the mass of its equilibrium position, tau is equal to mg L into sin theta, mg sin theta into L or I into alpha. For small angle of oscillations sin theta, theta is negligible here. Therefore I alpha is equal to mg L theta minus mg. Why I am mentioning here minus? Because the displacement of that bob is one direction, and the acceleration of that or the motion of the bob is in other direction. So that's why I alpha is equal to minus mg L theta. Here sin theta is equal to instead of theta because angle is very small. Actually there should not be a lengthy amplitudes. Remember one thing, while doing the experiment, the amplitude must be a very very small. The people must they may think the playing for a simple purpose they may extend their amplitudes, but that's not the way of experiment. So alpha is equal to minus mg L theta by I, minus omega square theta is equal to minus mg L theta by I, where omega square is mg L by I, or omega square is equal to root of mg L by I, and using this I is equal to ml square, I is equal to ml square. So ml gets cancelled, and remaining thing is 1l. Therefore, the time period of simple pendulum is given by t is equal to 2 pi by omega 2 pi into under root of L by G. This is the derivation. And energy of a simple pendulum. From the above figure, potential energy of the bob at B with respect to A and B are extreme points. mgh is equal to mg, h is nothing but L minus L cos theta into h, mgl into 1 minus cos theta into cos theta is equal to 1 minus 2 sin square theta by 2, where cos theta is equal to sin square theta by 2, isn't it? So mgl into 1 minus of 1 minus 2 sin square theta by 2. From the small angle sin theta by 2 is equal to theta by 2. Potential energy of simple pendulum is 1 by 2 mgl theta square. 1 by 2 mgl theta square. And the case of kinetic energy, half f omega square is equal to half ml square d theta by d theta whole square. That is the differentiating of the angle here, and differentiating of angular velocity. So omega is equal to d theta by dt. So half ml square theta square omega square cos square of omega t, and half ml square omega square theta square and 1 minus sin square omega t. Cos square theta is 1 minus sin square theta. Generally sin square theta plus cos square theta is equal to 1 kada. So from that I will write cos square theta is equal to 1 minus sin square omega t, implying that formula. And the kinetic energy of simple pendulum has become half mgl theta 0 square. That means minus half mgl theta square. Mechanical energy of the bob is equal to kinetic energy plus potential energy of the bob. That means Ke plus Pe, or mg half mg L theta square is equal to constant. Now coming to generally, and the motion of a body, it consists of velocity, displacement and acceleration and everything, isn't it? So when you plot the displacement, velocity and acceleration during simple harmonic motion against the time graph below, the velocity equation simplifies the equation below we just want to know here. Yeah, here you could see this, how it acts with respect to time. This graph shows clearly. The first one is a displacement. Okay. In case of displacement, we start with the positive x-axis and positive y-axis. Okay, this graph, and yeah, if I change, it will be clear, I think, right? Now coming to just sorry. Here what you can refer, something you can have an idea. This మీకు ఐడియాని ఇస్తుంది, displacement, velocity and acceleration. Okay. Now coming to seconds pendulum, children. Okay, a seconds pendulum is a pendulum whose period is precisely 2 seconds. 1 second for swing in one direction and 1 second for returning swing. At the frequency of 12 hertz, a pendulum is a weight suspended from a pivot so it can swing freely. A time period whose uh, a time period whose a pendulum whose time period is 2 seconds for one oscillation. Uh, there should be a graph actually. Graph ఉంటుంది. In that graph, uh, an experiment of LT square, you will get uh, that means in graph of LT square, if you exactly bisect its angle 90 degrees and put the values of L on side and T square values on one, then uh, divided by 2, you will get that time period. So the generally in many experiments we came to know that they studied that for exact 1 meter, the length of the pendulum will become as a seconds pendulum. That means the time of that pendulum will become as a seconds pendulum. That means for exact 1 meter length of the pendulum, it takes 2 seconds for one oscillation, and before that it will not take. As the time decreases, uh, what happens actually? Uh, the oscillation time decreases as well as the time period also decreases. And children, one more thing, from this time period t is equal to 2 pi under root of L by G, there are two things, two more laws we can study by deducting this derivation, or we can elucidate, we can find out this time period. The first law says that the time period of a simple pendulum is independent of shape, size and material of that bob. ఆ బాబ్ అల్యూమినియంది కావచ్చు, ఆ బాబ్ ఐరన్ది కావచ్చు, ఆ బాబ్ వుడెన్ది కావచ్చు, బట్ ఏ మాస్లెస్ అని మనం మెన్షన్ చేసుకున్నాం. బట్ ఈవెన్ దో ఇట్ ఈస్ ఇండిపెండెంట్ ఆఫ్ షేప్, బికాస్ విత్ ఎవ్రీ డిఫరెంట్ మెటీరియల్స్ you will get the same time period for one oscillation. And one more thing, the time period is independent of not only material, the time period is independent of shape also. If you hang that flexible inextensible thread with the help of what we call a rectangle, a square or a cube type materials, at that moment also you are going to get the same time period. And it is independent of size also. You take 100 grams weight content bob, you take 50 grams of weight content, you take 1 kg of weight content box, isn't it? It will take the same time, children. The time taken to one oscillation is independent of shape, size, material and uh, shape, size and material. Okay, irrespective of this, the time will be same. Next, and from this figure I can say that the time period 2 is equal to 2 pi under root of L by G. The time period t is proportional to under root of length of the pendulum, under root of length of the pendulum when G is constant. You take ఇప్పుడు 2 to 3 pendulums తీసుకోండి మీరు, లెంత్ పెరిగితే టైం పీరియడ్ పెరుగుతుంది. యాజ్ ద లెంత్ ఆఫ్ ది పెండులమ్ ఇంక్రీజెస్, టైం పీరియడ్ ఆల్సో increases, no doubt about it. For example, if L1, if a length of the pendulum is 10 centimeters, another length is of 40 centimeters, another length is of 80 centimeters, right? Then in these three conditions, the time period will be different as the proportional to the length, square root of its length, not only length, square root of its length, and inversely proportional to g. Time period is inversely proportional to g. And if acceleration due to gravity under root of g, not only g, under root of g, and if acceleration due to gravity is less, then time period will be large. If acceleration due to gravity is high, then time period will be very less. So based on this, three laws are there. The time period of simple pendulum is independent of shape, size and material of the bob. The time period of simple pendulum is proportional to the square root of its length. And time period of simple pendulum is inversely proportional to acceleration due to gravity, right? So this is about the simple pendulum concept, children, and you can have the figure from here, from this PPT, from the pendulum of the derivation, figure for the pendulum of a derivation of time period. And we can also derive in another method, not only this, another method by using Newton's second law, force is equal to some mass into acceleration is there, na? So from that also there are two ways of derivations. So you can go ahead with which you are interested and which you feel somewhat better or easy. Okay. And energy of simple pendulum is new in this concept. You don't have in syllabus, even though I have discussed about this. Velocity, displacement and accelerations graph. Many of the people, they don't have the idea of velocity, displacement and acceleration. A very simple definition is speed is a distance by time. The rate of change of distance will give you the displacement. The rate of change of displacement will give you the acceleration, isn't it? That means speed is equal to distance by time. Then displacement s is equal to distance by time, speed by time. Then the velocity is equal to displacement by time. Then acceleration is equal to velocity by time. And they are forgetting to write the units. Okay, in physics units are most and very very important whenever we go through all the physical quantities, or if we answer in a every physical quantity, then we have to remember the thing of writing its physical quantity. You should not forget writing the physical quantity. So this is one thing, children. And in this class we discussed about what you call reverberation time, Sabines formula and echo, right? The applications of echo too, adi kuda chadivinam kada. The echo definition, echo applications, Sabines formula and reverberation time, and the definition of simple pendulum also, simple pendulum time period, isn't it? And what we call derivation time period of a simple pendulum, right? Figure of pendulum for derivation of time period, energy of simple pendulum, loss of simple pendulum also we studied, loss of simple pendulum, and another one, the time period of simple pendulum, loss of simple pendulum lo 4 laws untai. The time period is independent of mass, shape, size and nature of the material of the bob. The time period of simple pendulum is directly proportional to the square root of its length of the pendulum, and the time period of simple pendulum is inversely proportional to square root of acceleration due to gravity, and the time period of simple pendulum is independent of amplitude, provided it is small, the time period of that means amplitude must be a small, so that you will get the accurate value in your experiment. So, and the seconds pendulum definition, a time period a pendulum whose time period is 2 seconds is called seconds pendulum. So, this is the class. Here I conclude, children, and yeah, in the next class we will go with another topic. Okay.